Okay, all this is a video of this is a video of a DC amplifier, and I'll just go over my circuit. Got a gain up about 50. So my DC voltage, I changed it for low level from so the variance in my DC supply is going to be, let's say, plus 10 millivolts down as low as minus 10 millivolts coming out of this pot. Okay, this pot is no, I thought I had it labeled. Oh yeah, it is labeled. Okay, let's move that label a bit there. It's VR1, which corresponds to VR1 over here. So I can adjust it over here. And you see when I put my mouse over, it goes blue. See? So you know which pot you're adjusting. So the voltage on the output of that pot is right here. Okay. So I can change it in real time. Like, so if you see me, you see how that moves? So it goes from 9 millivolts all the way to 9.9. There's a little error because the pot only has a minimum of 5 ohms for some reason. So it's a 1K pot. But anyway, that's not a big deal. That's just how they've set it up in the software here. And this is just more or less an oscilloscope. It's the same thing as this, really. It's just that if you had AC, you could see a waveform here. For DC, I don't really need these. So my second point that I'm monitoring is right here. So you can see it's the same thing. It corresponds to this oscilloscope. Third point I'm monitoring is right here, and it's right here, and corresponds to this oscilloscope. The next point I'm monitoring is right here. And it corresponds to this oscilloscope here. Okay, and then the last one I'm monitoring is the output. Okay, and it corresponds to this oscilloscope. Of course, you can see the voltage. So for what we're doing, we can just look at the numbers here. And okay, so if I vary the voltage on the input, so my lowest voltage is when I'm fully right here. I've got minus 10 millivolts. My output here is minus 488. And if I go to the lowest, or which is the highest setting here, I get the positive setting here, 453. Now there could be a little bit of tweaking to get these exact so that they're exactly proportional. 9.89, let me just check that. Yeah, because these are a little off too. They're not the same. It's not exactly 10. But anyway, you'd want to make everything exact here, and then you could calibrate the output. And to calibrate things, I could use these 2 pots. So of course my input, I want to go from, these 2 ranges. And then this here, this is just a buffer, really. So I guess you might be able to take that out, but maybe it helps because any reflection from the 10K could cause loading. Maybe it'd be minor. It seemed like I needed this, a pull down resistor to ground, just anything high. I'm not sure in real life if you'd need that or not, but the simulator seemed like I just put a high value here to ground from the emitter. You can't just leave the emitter with really high impedance, I guess. So anyway, that's just something that, and if you, okay, so I'm gonna watch okay, now when I'm at the maximum voltage on the input, I get maximum out, but pay attention to these voltages, what I get on the maximum. So my maximum voltage here is close to 10 millivolts, but my the voltage at this point is minus 1.25. Now let's go to the other way, the other extreme. Okay, now I'm at minus 9 and I got minus 1.257. So the range in this spot, pay attention to the range in this spot. It's not that much. So minus 1.25 to minus 1.257, right? You see there's a very slight range there. And that goes into, and then follow this range here. If you look at this range, it's a little different, right? Because there's a drop, I guess, across that diode here, the emitter base. So that range there, when I vary, is, let's say, minus 874 to minus 867. Okay, so there's not a lot of range there, but then take a look at this, right, over here. Okay, what do we got there? Now this will be inverted. So this would be minus 294 to minus 196. So there's definitely more range there. And we've got gain there, eh? I guess the theoretical gain is like 20, I guess. Is that right? Yeah. You can work all this out. Eh? I haven't really done too much math on it yet. And then I took that. So this signal, I took this and I pump it into here, and I balanced everything so I get the even swing here on this output. Right? So yeah, 488 to 453. Now these two resistors here, this is a 50K and a 1 meg, and I did this for fine tuning because it allows me a little more precision on that, and maybe even not quite enough precision. So that might be why I got some difference here. I haven't really monkeyed with this yet. So the other thing I might be able to change, since I've only got about plus or minus half a volt on the output, I probably don't need 12 here. You see how I changed this to 2, minus 2? I maybe only need maybe a plus 2 or plus 1 on here or something like that. So I can experiment with that. Or I could make, um, like I'd like to make an output stage that has a wider swing than just half a volt. But right now that's actually pretty good because most of the time when I'm playing around with DC voltages and I want to amplify them, I'm usually have a situation where I got a fairly low level and I want to boost it up to a very usable level. And this is fairly usable for most stuff, like trigger circuits or stuff. But so this amp, actually, I look for stuff like this on the internet and I really couldn't find it. Everything is op amps, op amps, and it's hard to find something like this. But this looks like it's running good in the simulator. I haven't tried to build it, so obviously that's something I can't do here. But you might want to try to put it on a breadboard and see what happens. But according to this is what we're going to get. So it's actually really nice. You get the positive and minus swings without using op amps and stuff. Plus, you could play around with the resistor values. Um, maybe go higher impedance. Maybe if you don't want to draw as much power and stuff. But experiment, experiment, experiment. Also, save this. This is this version of Falstad is the local version that I've got installed in my desktop. So it's very easy to just download it. It runs right away. No fooling around with this one. And if I want to save this circuit, I just go File, Save As, and then it's actually a text file, Palm. So I'm just going to save it as version 5. It's a text file, right? That's all it is. And when you want to open it up, you just go in here and open, right? Open file. I'll show you. I'll open a different one. I'll open one that I was experimenting with the other day. Okay, so it's going to be totally different. You see, a totally different thing comes up. I'll go back to the other one. Open, open file, and we'll go back to version 5 we just had, and it pops up on the screen. There we go. So this is actually extremely easy to use. You should learn how to use the software. It doesn't take long, maybe just a few hours, and you'll be up and running and save you a lot of time because I don't have to pull out resistors. I don't have to monkey around with like batteries or voltage source. I can just change it on the fly. Like you can edit these just by right clicking, edit. I can change that voltage to any voltage I want. I can change the labels, edit the label, I can change it to anything I want. I can move the label around, you see. Um, these things are just connected, make sure they're connected to the right point or you'll get an error or it'll say no connection. There's a few things, that might trick you a few, but it's a very, very, very easy program to learn. And it seems like it's very robust. I don't think there's any bugs in this program. It just seems super duper robust. But you can change a lot of parameters on the scopes. These are oscilloscopes. You can right click on it, go to properties, right? And you can change vertical scale, horizontal scale. Um, so it's good. It's good for, like most work for testing stuff. It's probably not good for really high frequency RF, but it's good for a lot of stuff. And so yeah, that's okay. If you want to add a scope, let's say you want to add a scope to this line, you just click on the line. Okay. See, can I click on that line? Where am I? Okay, this line is is that highlighted? If it's highlighted, as soon as it's highlighted. So then I would just go right click on it and say, uh, let's see, view new undocked scope. There's my scope. Okay. That's for that line. Okay. I don't need that, so I'll delete it. But I can also, see, I think I can also, see, well, you can add all kinds of stuff, Paul. I don't want to you know, if you go through the tutorials, it's extremely easy. Like even these things, this is just a probe, right? Let's see if I can see what that is. Internal component. Okay. So all this is like a like thing for measuring. So all that is, like say I want to put one up here, I can just right click, and I think that is an in output analog output. That's what that is. And then I see I get a cross, and then I can just go like this, and now I got an output, right? And if I want to add a scope to that, okay, and I got to go to deselect, right click and deselect. Now, if I want to add a scope to this, I would right click, right? And um, yeah, you undock scopes. So, oh, it went down here, kind of jumped away. That's it right there. And you can tell when you come mouse over it, that goes blue. The line goes blue there, you see? Both lines go blue. So let's say I don't need the scope, but I want the voltage. I want a voltage. Well, then I just click on this and go edit and see where it says show voltage. Click that line. See, now I got a voltmeter there. So, I mean, imagine you playing around with your scope probes. Well, these are all monitoring in real time, all of these. And now you don't have to get out your oscilloscope probe and probe this and then set the range. And then maybe your breadboard is buggy. It's got an intermittent connection, right? So there's tons of advantages to doing this. It's just so much quicker, right? And like I say, I have all kinds of problem with breadboards, as I mentioned. So it has its place. It's just quick. And sure, if you're really good with your math and you can maybe do this quick, I don't know. I'm not. I like to check things and prove things because maybe there's some areas I'm not 100% sure. This is a great way to check and make sure you got a working circuit. See, look, I've got a working circuit already, and I didn't spend too much time on it. I probably spent maybe 3 or 4 hours working on this, and right from start to finish, I got a DCM. Now I can fine tune this, make it better, you know. But anyway, I'm gonna upload this video and let you see it. Okay? All the best. Happy New Year to you anyway.